So in this video, we want to look at the operations of set. So I'll be using the given example to explain the following terms in set: union, intersection, difference, complement, Cartesian product, and cardinality of set. Explain what A union B is. First of all, you need to know that the union of sets A and B is a set that contains the elements that are in A or B or in both. So how do we realize that? Well, look at the elements in A. We have 1, 3, 4, and 7, while the elements in B are 1, 2, 5, and 8. So A union B is also a set that will give us the elements in A. What are the elements in A? We have 1 in A. We have 2 also in B. So it is the combination of everything in A and in B without repetition. Take note of that, without repetition. So this is our A union B. Also from the question, we are to determine what intersection means. So when we say A intersection B means is a set as well. A cell that contains the elements that are common to A and B. That is the elements that you can find in A and at the same time you can find in B. So what are those elements? When you check carefully, you can see that we have just one. We have just one. The third one is the difference. So when we say the difference, we are talking about A minus B or B minus A. So you can say that this can be defined as a set as well. That is, A minus B is a set that contains the element that you can find in set A but not in B. Why this means the element is a set as well that contains the element that can be found in B but not in A. So let's do that. A minus B is a set. So what's a set? What are the elements you can find in A? Those are 1, 3, 4, and 7. What are the elements you can find in B? 1, 2, 5, and 8. So those elements that you can find in A, but they are not in B. What are those elements? 3, 4, 7 are not in B. 1 is in B, but 3, 4, and 7 are not in B. And this is the answer. Then for the next one as well, one which is B minus A. What are the elements that can be found in B but not in A? 1 is in B and also in A. So 1 is out of the set. We can find 2, 5, 8 in B but not in A. So this is the difference. So you say A minus B as a set, you get this. B minus A as a set, you get this. So number 4, which is the complement. The complement of the set A is the set that contains the elements that you can find in the universal set but are not in A. What does that mean? It means if this is A complement, or it is also denoted as this complement, it is also a set. Or before I call it a set, let me say it is a universal set minus A, just like the previous one. The elements that you can find in U but you cannot find in A, meaning that universal set minus A. And as we know that the universal set is the set that contains all the elements in consideration. This is the universal set. So you compare the universal set to set A. So what are the elements that you can find in the universal set but not in A? 1 is in A, 2 is not in A. So you begin to write 2. What else? 3 is in A, 4 is in A, 5 is not in A. 6 is not in A, 7 is in A, 8 is not in A, 9 is not in A, and also 10 is not in A. And that is our A complement. And number 5, the Cartesian plane of set A and B. The Cartesian plane of set A and B can be defined as the set of all ordered pairs. When I said all other pairs, I'm talking about in the case where A is an element A and B is also an element in B. We are going to look for the pair in ordered manner, A, B. So the Cartesian product of A and B can be written in this form. Cartesian product of A and B. So in this case, all you do is that you pick, this is A cross B. So you pick the first element in A and you attach it to everything here, one after the other. Let's do that. I have something like this: 1, 1, 1, 2, 1, 5, I have 1, 8. You still continue again. You use 3 now. We are picking 3 now. You pick 3 to 1, 3 to 2, 3 to 5, 3 to 8 as well. So let's do that. So we have 3 to 1, 3 to 2, 3 to 5, 3 to 8. And the fourth one is 4 to 1. Good. 4 to 2, 4 to 5, 4 to 8. Why the last one is 7 to 1. Good. 7 to 2, 7 to 5, lastly 7 to 8. And this is very easy. You just pick one of this to all, the next one to all, the next one to all, last one to all, and you get this. That is the Cartesian product of A and we are given that the universal set is A, B, C, D, E. This is the set A, set B, and set C. So we have to determine the following. The number 1 says A intersection B. A intersection B is the set that contains the elements that are common to A and B. And if you look carefully, you see that the only elements that you can find in A and also find in B is A. And that is the answer. And the number 2, A union B, is the element that you can find in A or B or both. The combination of all the elements in A and B without repetition. A appears in A and B. Just write one of them. Then B is there, E is available, D is available, and letter E. And the number 3, we have A intersection B complement. Very easy. When we say complement, it means that the universal set minus the set. So A intersection B is a set that we already know, which is a set that contains element A. So all you need to do is you look at the universal set and subtract the one element that you can find in A intersection B. So that means we'll be left with B, C, D, and E. Then number 4, we have A union B intersection C. This is also easy as well. Very, very easy. So in this case, what is our A union B? A union B is already known to be A, B, C, D, E. What is our C? Our C is A, E. So what do they have in common? That is the meaning of intersection. So what they have in common is A. You can also see A here, E and E. So what they have in common are A and E. And the last one, which is A union B complement intersection A intersection B. Very easy. What is our A union B complement? A union B is also known to be A, B, C, D, E. So if you have to take away all this from the universal set, what are you going to be left with? You will be left with nothing. That is an empty set. So this is like saying this is an empty set and A intersection B. So you are looking for the intersection of an empty set with A intersection B. And our A intersection B is A. Do they have anything in common? Definitely no. So which means that the result of this is an empty set. Is an empty set.